Alrighty, what's up YouTube? Welcome back to Cybersecurity with Ruby. This is Corey's Corner. Be sure to check out the Corey's Corner podcast on Apple Podcasts and Spotify. But anyway, enough with all of that. What we're going to be doing today is we're going to be going over how to encrypt data with the AES algorithm in the Ruby language. So AES is a symmetric encryption algorithm, which means that we use one key to both encrypt and decrypt our data. So the AES algorithm basically takes 128-bit blocks of data and encrypts them at a time. If the data is less than 128 bits, which this is, it will pad the data with some, dummy encryption text, I guess. But anyway, so if you're not familiar with terms, don't worry, we'll go over that in a second. But the first thing that you need to do is you need to require the OpenSSL library and create some secret data that you want to hide from your potential enemies. So the first thing that we're going to be doing is we're going to create a Cipher object, and we'll store that in a variable called Cipher. And to do that, we open the OpenSSL library. So OpenSSL is just a common encryption protocol, and we get a Cipher object, and we're going to create a new Cipher object. And in here, we're going to just going to pass in the encryption algorithm that we want to use, AES. We're going to encrypt. We're going to choose our key length, which we'll do on a 256-bit key. We're going to do a Cipher blockchaining mode algorithm. So AES, I'm not a mathematician, can't really get in the algorithm, but the key is what's used to unlock and lock the data. So a longer key is obviously harder to brute force, which means that the encryption is more secure. And Cipher blockchaining is pretty cool. It is a mode. So rather than encrypting the plain text right away, what's going to happen is that each block of plain text is going to be XORed against the ciphertext of the previous block. So if we have two 128-bit blocks, the second block will be XORed against the first block, and then will that be encrypted. But obviously, our first block can't have anything to be XORed against, so it gets XORed against a random initialization vector. This is all from Wikipedia. I thought blockchaining was a relatively new concept, but it's been around since 1976. Who knew that? And people are paying for spots on a blockchain that are worth like hundreds of thousands of dollars. But anyway, that's a different story for another time. And if we look at the AES Wikipedia page, we'll see that, it takes different key sizes, 256 being the largest. I don't know why you would use 128 or 192. I think 128 is actually broken, but please don't use the Corey's Corner YouTube channel as cybersecurity advice for your super sensitive enterprise applications. So the first thing we're going to do is we want to initialize our Cipher object for encryption mode, so we just call the Encrypt method on it. And the great thing I like about RubyMine is if you don't know what a method is, these little helpful pop-ups will, they'll come up when you hover over a method. So we can see, the encryption method initialized. This is the OpenSSL Cipher for encryption mode. The next thing we want to do is we want to generate a key that will be used to lock and unlock our data. So we can call cipher.randomKey, and we'll just put the key out to the screen, and then we want to create an initialization vector, so we'll call cipher.random IV, and we'll print that out as well. We'll just run our file for now. Also, so clear. So we do Ruby symmetric.rb. You'll see that we get this and we get this. Yeah, I don't know why this is printing like this. But I'm just going to ignore it for now because I know this works. Sorry. But anyway, it'll probably look different on your system. I think my terminal's messed up or something, but whatever. So now we want to encrypt our data. We want to create some encrypted data. How do we do that? Well, we're going to create an encrypted variable, and we just call cipher.update on our data. Obviously, we can see that the update method, that is ultimately what encrypts our data. But if our block is not 128 bits, it needs to be padded, which is why we call the cipher.final method. What is this? Why am I getting this yellow line? Oh, because it's not being used, but we're going to use it. So we can print out the encrypted data like so. We'll just erase these because we don't need these anymore. So Ruby. And we get our encrypted data. All right, so we've secretly stored our data, but now we want to decrypt our data. So obviously we wouldn't be doing this all in one file. We would take our initialization vector and our key, and we would store those somewhere else. For transmitting things like keys and initialization vectors, we would probably transmit those to other people in our workplace or whoever else we're working with asymmetric encryption. And a lot of I forget the protocol name, but it might be the TCP handshake. I believe they take a symmetric key and they exchange the keys, or they calculate the keys with asymmetric encryption. But we're gonna go over asymmetric encryption in the next episode. But let's get to deciphering our AES 256 algorithm, our AES cipher right now. So we'll create a decipher variable, which will hold another open SSL object. It'll be cipher.new, same thing, AES-256-CBC. Obviously, we need to use the same key length and the same mode, and obviously the same algorithm. And then we're going to set our mode to decrypt, initialize it to decrypt, and we'll initialize the key like so. And our IV like so. Obviously, we would store these in files or something like that in a real context, but we're not going to do that right now because we're just trying to learn the fundamentals, but you can experiment that on your own if you want. So we're going to do decipher.update encrypted, and also we need to worry about the padding again, and we will print out our plain text like so. We see this is our encrypted data, and then this is our deciphered data. So congrats, you know how to perform symmetric encryption with the AES algorithm using the Ruby language. You can try, I'm not going to do this as a video, but you can try saving the key and the IV to a file, then reading those, and create, one file for encrypting, one for decrypting. You can try out the other symmetric encryption algorithms. But yeah, I encourage you to play around with the Ruby methods. But that is all for this episode. Please subscribe, check out the Corey's Corner podcast. I will see you in the next episode. I really appreciate you watching this, and I hope that you learned something. Peace.